Hi guys, so moving on with the second lesson of this new unit. Um, we talked about some exponent rules in the first lesson, and we're going to continue talking about a couple of more. So today we're going to deal with zero and negative exponents. So when you have a power of zero, or if you have a negative exponent. Okay, so looking at number one over here, it says evaluate first by canceling and then using exponent rules. So if we disregard this bit right here, right, because it says evaluate first by canceling, let's look down here, and if we're going to do this by canceling, we have 9 squared in the numerator, which is 9 times 9, and then we have 9 to the power of 5 in the denominator, which is 9 times 9 times 9 times 9 times 9. So these two 9s in the numerator can cancel out with these, well, any of the two 9s in the denominator, which leaves us with 3 9s in the denominator, and then because these 9s canceled out, we have a 1 in the numerator. So this then is equivalent to 1 over 9 to the power of 3. Okay. The other way to do this, the quicker way to do this without canceling, would be to use our rules when we are dividing exponents with the same base, and that is to subtract the exponents. So 2's in the numerator, 2 minus 5, which is in the denominator. So you subtract the two exponents, 2 minus 5 gives us negative 3. So 9 squared over 9 to the 5 is equal to 9 to the negative 3. All right. Same way if we go to part B here. If we do it using exponent rules, we have 7 squared over 7 cubed. So again, we're dividing. So when we divide with the same base, we subtract the exponents. That's why we have this 2 minus 3 here, which is equivalent to 7 to the power of negative 1. If we did it the canceling way, 7 squared is the numerator, 7 times 7. 7 cubed is the denominator, 7 times 7 times 7. So these two 7s cancel out with these two 7s, leaving us with 1 over 7. Okay. And 1 over 7 is equivalent to 7 to the negative 1. Just like over here, we saw 1 over 9 cubed is equivalent to 9 to the negative 3. And very much the same way in C here. We have 2, and anytime we don't have a power listed there, we know we have that imaginary 1. So there's 2 to the power of 1 over 2 to the power of 5. And again, same rule, we're dividing, so 1 minus 5 gives us 2 to the negative 4. Okay. And here's the long way of doing it in terms of canceling. We have 2 over 2 times 2 times 2 times 2 times 2. This 2 and this 2 cancel out, leaving us with 4 2's on the bottom, or in other words, if you have 4 2's multiplied by each other, it's 2 to the power of 4. So 1 over 2 to the power of 4 is equivalent to 2 to the negative 4. Okay, so summarizing that bit there, if we look down here, when a power has a negative exponent, it is equivalent to 1 over the same power, but with a positive exponent. Okay, so what does that mean? Basically, if we have, in this case, if we look up here, we have 9 to the negative 3. That's the same thing as 1 over 9 to the positive 3. So what you do basically is you flip the base, so 9 becomes 1 over 9, and the exponent becomes positive. So instead of negative 3, you have positive 3. Here you had 7 to the negative 1. The base is 7, so 7, if we flip it, becomes 1 over 7 to the positive 1. So that negative 1 exponent changes to positive 1. Same thing over here, 2 to the negative 4. If we want to change that to positive exponents, what do? We flip the base, so 2. And remember, 2 is the same thing as 2 over 1, right? 7 is the same thing as 7 over 1. 9 is the same thing as 9 over 1. So what we're doing then is taking 2 over 1 and flipping it to 1 over 2. And by flipping it, we are able to then change this exponent from negative 4 to positive 4. Okay, so that's what's being shown here. Okay, so if you have a number, you basically do 1 over that number and then change the exponent to positive, right? Negative x became positive x. If you have a fraction, the same idea applies. You flip it. So if this was 2 over 3 to the negative x, we would flip it and make it 3 over 2 to the positive x. Okay. So anytime you have a negative exponent, you can basically flip the base and change that exponent to positive. So there's your first rule for today's lesson. Moving on to the second rule, we have here, it says evaluate first using exponent laws and then by canceling. So over here, if we use exponent laws, we know when we're dividing with the same base, we subtract the exponents. So we have 3 minus 3 gives us 2 to the 0. Here we have x cubed over x cubed. So again, subtract the exponents. So x to the power of 3 minus 3 is x to the 0. Okay. But we also know that anytime you have a number over itself, so the same number in the numerator and the same number in the denominator, these two will cancel out and basically give us 1. Or same thing if we have the same variable and exponent, same variable and exponent. So you have the same thing in the numerator divided by the exact same thing in the denominator, that gives us 1. So long way of saying basically anything to the power of 0 equals to 1. Okay, so it can be any number, any variable. It doesn't matter if it's to the power of 0, it equals 1. If you had 10 million to the power of 0, it still equals 1. If you had negative 700,972, whatever, to the power of 0, it still equals 1. Okay, so there are your two rules. So you have your negative exponents, flip the base and change the exponent to positive, and anything to the power of 0 is equal to 1. Okay, so there's a summary there again. Okay, so your 0 exponent rule and your negative exponent rule. Okay, just to go over a couple of examples here. Again, it says evaluate without a calculator, so we're going to look at 4 to the negative 1. Basically, we know when we have a negative exponent, we flip the base and we change the exponent to positive. So 4 to the negative 1, if we flip the base, 4 becomes 1 over 4, and that negative 1 becomes to the power here of positive 1. Because it's to the power of positive 1, it doesn't change anything. We don't have to write the 1 exponent there. Okay, so here we have 7 to the negative 2. If we want to evaluate that without a calculator, what do? We've got to change that negative exponent to a positive. How do we do that? We flip the base, so 7 becomes 1 over 7, and the exponent becomes, instead of negative 2, becomes positive 2. Now we can evaluate. 7 squared is 49, right? So the final answer here is 1 over 49. Moving on here, if we have a negative base, so we flip the base, so basically the base is negative 6, so basically you don't change anything on the negative 6. All you do is move it to the denominator. So it becomes 1 over negative 6 to the power of positive 3. So notice here, the base, the sign was negative, that stayed negative. So you never change the sign on the base, you only change the sign on the exponent. So the negative 3 exponent becomes positive 3. Okay, so negative 6 to the power of 3 is negative 216. Okay, so the final answer here is negative 1 over 216. And no, it doesn't matter if the negative is written up there or down here or in the middle. As long as you're showing that somewhere there's a negative, the fraction is negative, then that's fine. Okay, so again, the error I see a lot of the times is students, when they flip this negative 6, they make it into 1 over positive 6. So never change the sign on the base, only change the sign on the exponent. Okay. And as we said earlier, with our other rule, anything to the power of 0 is 1. Okay, same thing here. If you look at h, doesn't matter what you have inside the bracket, as long as a 0 is there, the entire thing is going to equal to 1. You could have 2 to the 5, 3 to the 6, a, z, b to the 4, whatever in the bracket. If the entire bracket is to the power of 0, the entire thing is equal to 1. Okay, so let me just go to e here. Here's an example where we have a fraction to the power, to a negative exponent, to the power of negative 1. So how do we deal with this? Just like these ones over here, we flip the base. So the base is 3 over 5. It becomes 5 over 3. Once we flip the base, that allows us to change this negative exponent to a positive. So then it becomes 5 over 3 to the positive 1, which is equal to 5 over 3. Okay. Last couple of examples here. So the same rules apply as the previous lesson, where if you have the same base and you are multiplying the powers together, you add the exponents. So here we have a base of 5, and they're being multiplied. So we take the exponents, so we do 3 plus negative 4. 3 plus negative 4 is negative 1, so that gives us 5 to the power of negative 1. And the last thing to do here is we want to make that negative 1 into a positive and evaluate this. So to make that negative 1 into a positive exponent, we take 5 and flip it to 1 over 5. So this becomes 1 over 5 to the power of positive 1. Again, don't need to write the positive 1 because it doesn't change anything. Okay, so here we go again with another example. Now we're dividing with the same base, so we subtract the exponent. So you take 4 minus 7 is negative 3. Again, anytime you have a negative exponent, you want to turn that into a positive exponent. So to do that, we take the base of 3 and we flip it into 1 over 3. And then the exponent, instead of negative 3, becomes positive 3. The last step then is to do 3 cubed, which is 27. So your final answer is 1 over 27. Okay, so they can get a little bit more complicated. Like I here, you have basically 3 different powers, right? But just follow the same rules as we have learned in the previous lesson and today's lesson, and you'll get to your correct final answer. So first things first here, I see I have a power to a power, right? 4 to the negative 2, and all of that to the power of 3. Based on yesterday's lesson, we know when we have power to a power, we multiply the exponents together. Okay, so negative 2 times positive 3 becomes power of negative 6. Okay, so now we have 4 to the negative 6 times 4 to the 5. Okay, and if we're multiplying with the same base, what do? Again, when we're multiplying the same base with the same base, we add the exponents. Negative 6 plus 5. Okay. Leave the denominator alone for now, right? That'll just be 4 to the 6, and it stays 4 to the 6. Simplify this numerator here. Negative 6 plus 5 becomes negative 1. And that leaves us with 4 to the negative 1 divided by 4 to the 6. And again, because we're dividing with the same base, we need to subtract the exponents. So negative 1 minus 6 gives us negative 7. Okay. Now we've finally simplified it down to one power, right? 4 to the negative 7. The last thing to do now to evaluate this is we want to change that negative 7 exponent to a positive 7. So just like with all the other questions we've done, to change a negative exponent to a positive exponent, we need to flip the base. So 4 becomes 1 over 4, and once we flip the base, that negative 7 becomes positive 7. So your last step then, and this you'd obviously do in your calculator, is do 4 to the power of 7. So our final answer is 1 over 16,384. Okay, so that's the lesson for today. You have practice sheet 2 for practice. Before I let you guys go, again, just to quickly recap, we had 2 new rules in addition to the ones we learned yesterday. So the first one listed here is when we have anything to the power of 0, it equals to 1. And the negative exponent rule, anytime you have a negative exponent, you always want to change that to a positive exponent, so then it lets you, it allows you to evaluate whatever the question is. Okay, so we can't work with negative exponents, so we always change them to positive exponents. How do we do that? Anytime you have a negative exponent, flip the base, so this b becomes 1 over b, and then the exponent can be changed from negative to positive. So the negative x becomes positive x. And then same idea over here. If you already have a fraction, or you have a numerator and denominator, you flip the base. So in this case, the base is a over b. Flip a over b to b over a, and then change the exponent to positive. So you can see the x became positive x, and it was negative x here. Okay, so hopefully that makes sense. As always, if you have questions, feel free. Do not hesitate to email and ask away at any time. And again, I will always do my best to answer whatever questions you may have. All right, guys, take care, and good luck with the lesson and all of your other schoolwork that you're working on, and stay safe.